I'm here today with Seth Ladd of Google. He's a web engineer and Chrome developer advocate. He's done previous work in a lot of different web fields. He's worked in Rails, he's worked in gaming, he's worked in HTML5. Lately, he's doing a lot of work with JavaScript and Dart, both at Google. And I'd like to start with something that's on your Twitter feed. You're at Seth Ladd, at SETHLADD for anybody who wants to find you. And it says, "We can do better." And that really sounds like the message you had at the JavaScript Summit a couple of weeks ago. I guess I'd like to hear more about what you'd like to see us do better.
Well, first, thanks, Simon, for having me. This is a real treat, and I'm looking forward to our conference, FluentConf, later this year. You're right. I do put as a motto, if you as a mantra, "We can do better." That just is a good reminder to me to always try to strive to do more, try to accomplish more, constantly evolve. It's something I'm trying to remind myself to never be happy with the status quo, to always push myself. And so I don't mean that specifically with technology by any means. I mean, that's how I want to approach life. And I think that we should all always be saying, how can we do things better here?
Okay. Well, let's bring it a little tighter. I mean, so and a strictly technology category, I think you definitely think we can do better with JavaScript. Kind of what are you aiming for? What would you like to see us accomplish with JavaScript? And the web generally. I think there are a lot of blurred boundaries there, and not everything is JavaScript's fault or JavaScript's glory. So, what can we do better in that space?
Yeah, great question. Multiple different angles, a way to approach this. For one, it's just kind of a lifestyle, right? We should always be innovating. We should always be evolving. So specifically, I think that we shouldn't be satisfied with the speed of web apps today. Certainly, JavaScript engines are getting faster all the time. And I have a lot of respect for the engineers that are able to take JavaScript, the scripting language as it was originally designed, and makes it run at really fast speeds today to power some larger applications. But but we shouldn't rest on those laurels by any means. When you look at what other platforms are able to accomplish with their runtimes and their virtual machines and their compilers, it shows that we have a long ways to go. And so part of it's just remember that we are faster, but we're not yet fast. So I think just continually pushing on that. There's different ways to kind of look or measure speed and performance. One is pure computation, and that's where the hardcore engineering at the VM comes in, and some awesome work around just-in-time compilers and what V8 does with Crankshaft.
Right, I was going to bring up V8.
And I know Mozilla's doing some good work there too. But then there's also speed and performance about web apps in general. So to your question again, what can we do better? I think that we as developers should be demanding 60 frames a second continually, no jank, no hitches, no matter what our app's doing. Could be animation, could be user input, could be pure computation, could be layout redraws. And so there's also performance around just the browser primitives and repaints and reflows. And these are just always understanding that what we have today is better, but it can always be improved upon. And to make our developer lives easier, like us as developers shouldn't have to worry too much about what are the intricate old wives' tales to get this reflow to work perfectly. And so just demanding more from the platform and continually pushing ourselves to deliver more fluid UI responsive apps is another thing I'd love to see us continue to work on.
Right. Well, kind of another angle on that. It's not just what you build with JavaScript, but how you work with JavaScript. I think people are trying to figure out how to work in teams with JavaScript, how to debug JavaScript, how to scale JavaScript to larger applications, and it sounds like you've definitely seen that.
Yes, absolutely. And this is something we'd love to see more larger teams build larger, more complex web apps running in the client in modern web browsers. And to do that, we believe that you need more structure and more tooling. So we can look at some of the efforts that we, at least inside Google, because we've had this experience around building large apps like Google Docs and Google Spreadsheets and Gmail, et cetera. we've built systems like Google Closure, which is a layer on top of JavaScript with a compiler that heavily optimizes your code, and you can add in things like annotations about types and method signatures, again, to help your fellow developers understand your intent when you're building these, because you might be working with 100 different people in different time zones, and you don't necessarily sit next to them. And so you need the code to kind of reflect your intention. That is, this method takes strings and it returns an integer. I mean, just simple things like that help tremendously. And then when you have that, the tooling infrastructure, the machine can start reading these kind of annotations or hints or implicit documentation and start giving you early warnings about bugs or possibly even optimizing for you. So we tried some efforts with Google Closure to do that. We also looked at Google Web Toolkit, which allows you to write web apps in Java, but then compile the JavaScript, so you take advantage of the structured nature of Java and some of the tooling infrastructure there. But with both of those solutions, they never were natural to the web. And they never really took off in the broader web development community. And I think one of those reasons is because they may possibly ahead of their time, they weren't native to the browser, and they didn't really work the way web developers wanted to work. So we want to try to accomplish or give developers more structure, more tooling, the ability to scale up, not only in complexity, but number of developers, but also with a system that feels natural on the web. And that's really hard to do, and that kind of brings us to Dart.
Yeah.
Dart is our effort to create a language and development environment and a set of practices and idioms, tooling, infrastructure, libraries, language that can appeal to a broad spectrum of developers that all want to come to the web. And on one hand, you might have JavaScript. And these are very talented developers working with prototypal inheritance. They haven't been using static type annotations. And they deal a lot with functions. Yep. And then all the way on the other end of the spectrum is you might have Java or C# developers who love to write their abstract class factories and yes. love their classes and interfaces and classical inheritance. And they have higher expectations of tooling and all that. Both spectrums are really valuable developers, but we think that we can bring them a little bit more towards the middle, add some structure for JavaScript developers, but pull back some of the high barriers and complex, static type systems that you might encounter in the other languages like Java and C#, and develop a language like Dart that is both iterative and scalable, and the great things about web development, but yet gives you classes and inheritance and abstract classes and static type annotations that can help teams scale to larger, more complex web apps. And so that's really what we're trying to do with that project.
So it's a bridge. It's a very large bridge between different programming communities in a way. Yeah,
that's a good. Yeah, we are trying to kind of appeal to both ends of that spectrum and help solve different problems depending on where you're coming from. It's definitely an ambitious effort, but we're still in technology preview, and so right. we're working hard to prove all this stuff out.
Right. Well, I'd like to just ask a little about the engineering behind the bridge. We talked a few weeks ago about compiling to JavaScript and the advantages and disadvantages of that. Dart seems to be in that general zone, but it's not clear that that's where it's always going to stay. I guess just as these parts go, how do you build from classic JavaScript web to the broader stuff you want to do with Dart?
Yeah, so we should probably be clear that the Dart compiles to modern JavaScript today.
Right.
That's an extremely important aspect of the project, and for many years from now, that will be job number one. In fact, there's kind of two core design constraints around the language. One, it has to be instantly familiar to a broad spectrum of developers, which is why it kind of looks like the languages we see today.
Right.
But then it also has to compile to logical, sane, and performant JavaScript. I mean, that is baked into the design decisions of the language today. Right. And that will be true for a while because Dart is for the open web. Again, we try to make something that feels natural and very webby. So that's really job number one. It's interesting design trade-offs. I love watching the language designers debate about, well, we'd love to add this feature, but it doesn't really compile to JavaScript very well, so we can't. And so I've seen them throw out perfectly awesome ideas because of that. Did that answer your question?
Yeah. And a few years ago, talking about logical, sane, and performant JavaScript would have been a difficult conversation in itself. So,
we're so lucky that we have the guys that used to work on the V8 engine, which is the fast JavaScript engine in Chrome, now helping with Dart. So these are the guys that knew how to make JavaScript fast. And so if anyone knows how to compile to fast JavaScript, it's hopefully these guys.
Right. And I'm very happy to hear, you want the JavaScript to be, readable to other people, to be webby. We kind of...
Yeah, so we should talk about that. So logical, sane, and performance. Readable was not in there.
Well, I know, but workable.
Yeah. Workable is probably a good way to say it. We can kind of look at it like the compiler probably knows more than I do, and we've always relied on compilers to generate logical, sane, and performant assembly code, for instance.
Yes.
But I don't read that assembly code. That's I definitely don't. I mean, unless I'm making a game, I guess. But so the same, JavaScript is essentially slowly becoming the bytecode of the web. I mean, you see how many languages compile to JavaScript now? I mean, probably 100, I think, is the last time I looked. And so yes, debuggability is important. I would say that debuggability is important. There's a couple ways we can accomplish that. One is the code that we generate logical, so at least you can kind of follow. Someday, who knows? I mean, there's some great things like source maps that allow you to map between the primary code language and the compiled JavaScript language. It's not quite on our radar yet, but I know a lot of people have asked. So at least there's a couple of potential solutions there to help developers get comfortable, because compiling to JavaScript is a primary target for Dart developers.
Right, and I think that's become less scary for JavaScript developers. We kind of live in an age when view source on code doesn't always bring up the original code, and people are developing.
Yeah, that's a fantastic point. I think every modern web app today has a build step, and part of that build step is to minify and obfuscate and collapse our code, both CSS and JavaScript. And so the way I think about it is, maybe GitHub is the new view source, right? As long as we as a community are still sharing the libraries that we build and the lessons learned, still writing these tutorials, I think view source is should be less of a concern if we're doing it right. I mean, if I can read it, that means I'm probably shipping too many bytes over the wire anyway.
Right, and that's a beautiful way to close a We Can Do Better talk. I think that GitHub offers those kinds of opportunities. So thank you very much, Seth.
Oh, my pleasure. Thank you very much, and I look forward to seeing you and everyone at FluentCon.
Great. Thank you.